It is truly my honor to introduce Devon Clark because he's one of those people who I could also lose my voice talking to at conferences. Just a wonderful person. We can have a conversation about anything. But he is a specialist in digital engineering at Deloitte. I knew that. And who's been pushing the idea that MBSE can and should move at the speed of modern software. And he's joined by his colleague, Dimitri Shaki, a systems engineer at Deloitte, who has been putting that argument into practice. So, my honor to introduce the two of them from Deloitte.
Thank you very much, Mark. Thanks for the opportunity to be here. This is really exciting. One of the things that's really nice about representing Deloitte in this capacity is that our perspective is a little different here. We are not an OEM. We don't make radar systems. We don't build engineering tools. We are a services firm that is primarily focused in the value and application domain. So this idea of systems as code, which we're referring to as models as code because we don't want to get anywhere close to copyright infringement. So this idea of models as code is very interesting to us and myself personally. Going back to about 2012, I have been really motivated by this perceived incompatibility between the software development lifecycle and the systems engineering lifecycle. And so it's really exciting for me to be where we are, where we're starting to get to this future of models as code and how we can start to get to a future of engineering at the speed of software. So a little bit more about myself. I lead Deloitte's Deloitte's engineering for government agencies, and I have been got 25 years of experience doing systems engineering, integration, and test, both as a government civilian and in industry. And today, my brand is really around digital transformation, which is why today I'm not going to get into the nuts and bolts of how we're doing this. I want to today spend a little bit of time as digital engineering futurist. And I want to thank my team. Dimitri is here with me to help answer questions, but there's a broader team there who have been exploring System LV2 to help kind of get us to where we are. So with that, let me go ahead and jump in. And I want to start by dialing back the clock back to 2018. All of us are very familiar with the digital engineering strategy, but I want to talk a little bit about kind of our perspective and use this as an anchor for where we're going in the future. So as you know, our definition was an integrated digital approach using authoritative sources and traditional system engineering practices to get to get to value. And while what we have seen across government and kind of commercial organizations is there's been a lot of focus on the engineering process itself and the engineering tools, rather than the broader view, which then takes into account culture and leadership and the underlying data and having reusable assets. And there have been some challenges which have kind of got in the way over time. But before I'm going to get to those on the next slide, I just want to take a moment to kind of talk about what at Deloitte, our view of digital engineering, what is the value that we are bringing? And the value that digital engineering is bringing. The first one is data integration. So really using your data and your models as a knowledge base that activate your outcomes. And then the second one is lifecycle efficiency. By connecting that knowledge base to our processes and operations, we're able to activate greater scale, greater efficiency, greater velocity. And that gets really to that third one, which is the accelerated value. By using these reusable models and data sources and knowledge base, we can get to innovation and rapid integration faster. Now, I'm sure, by a show of hands, I know I'm online, I'm not going to see everybody in the room, but I'm sure if I say that's been everybody's experience, that's what you've experienced, yes? My hunch is that probably not, because what we have experienced is really an ecosystem challenge. We have the models there, but the connections aren't. And so what that's tended to do is to create model-based systems engineering as its own new silo. And so what the challenges that we need to overcome, which we're not going to solve all at once, but we can make improvements on, and I really do believe that V2 is doing that for us. But the challenges we've seen are we have this new silo. Our engineering data has been trapped and made difficult to use by other tools, which gets us to the middle of brittle integrations. model-based systems engineering is supposed to be, and these models that we're using has supposed to have been to activate and create this one glue to tie all the tools together. But what we've experienced in reality is that tool interoperability has not been something always that's been prioritized, and we have fragile links that require point-to-point bespoke solutions. And what that has ended up, and then in the meantime, we also have the stakeholder problem where we have a gap between between the models and how they can become out of date as things are changing, and we're not getting visibility to our decision makers. So what's now V1 has been contributing to this largely through because XMI has not been has been something that is primarily focused in our tools, and everything has been connected into this specific tooling, which makes the V1 models very hard to track changes against. And like I said at the top, there's this historical perspective that Agile has been very disconnected from system engineering. So our model-based systems engineering flows are not tied into our continuous integration and continuous development pipelines. So the future of digital engineering, the future of model-based systems engineering, has got to make improvements on this and the way to do that is to treat the V2 text notation as readable by machines and AI to allow us to address some of these accessibility and interoperability gaps. So here is our view of the future, right? And then the point is that to some degree, those challenges that we just laid out, they're always going to be there. We're always going to have a large ecosystem of different teams, different providers, all with different methodologies and different levels of maturity in doing this work. We're never going to fully solve it, but we can make meaningful improvements, and by really focusing on the integration of all of these different domains of AI, which we've already had some presenters talk about today, and the usage of AI, with our DevOps and our CI/CD pipelines, tying into the software management type of approaches, and now treating those as model management, being able to do diffs and audit of code, and using existing tools to then also get to validation, some of what we just heard about as well, and then tying that all together with the larger ecosystem of engineering tools, with the SysML tool text notation kind of being this hub in a hub and spoke model. And what that will do is that will connect models as code, agentic AI, and our CI/CD pipelines into one big digital thread, all of which gets us a system that is both alive and continuously updating and able to drive the kind of change what we're doing. So all of this to say that we're going to this will deliver engineering at the speed of software, where the rigor is baked in and embedded. So the benefits for actually getting to the approach that we just saw is that, again, like, text is for the machine, but diagrams are for the stakeholder. So in the future of digital engineering, what we're going to see is that is basically the one common knowledge base, but kind of two different interfaces to it. We're going to have the engineers writing directly into these models, and then that's fueling all of the applications I was talking about earlier, where we can see the inner workings of and decision making required to mature our programs. So engineers write, stakeholders see. At the same time, one of the challenges I think that we've all probably experienced is around the accessibility of these models to non-engineers, right? So, and historically, what we've needed is, you have in order to really get into the quality of the models and the knowledge that's there, we have either needed some very bespoke script that would extract information out of the model, or we need some really highly specialized semantic experts who could then do the brute force and get through and identify what mattered to us by really understanding the inner workings and the under the hood semantics, and all of that. And so in the future, we're going to be able to use AI and these kind of chat interfaces to let the agents have that expertise, that semantic expertise, so we can just have plain language conversations, or our PMs can have plain language conversations with the engineering knowledge base in order to extract value much faster and increase adoption. And what is that all going to lead to? It's going to lead to that hub and spoke model, which has been eluding us, where we have the V2 as text, we have a growing ecosystem of other applications and other specialized engineering tools that are interfacing with each other, which so far has been point to point. But if we can get to this future of using the V2 text models as the hub, then they all only have one point they need to integrate with. And that should help us to get closer to this future that has eluded us. So the next two slides, I'm going to just take a moment and really kind of talk about what we think that future looks like. So right here, we're going to talk about kind of the AI loop. On the next slide, I'm going to talk about the agile loop. So in the future, as we look at kind of this AI approach to modeling, so far it's still all very much been input, output, and then make changes as needed in order for decisions. But the people collecting those inputs, doing the work in the model and then generating those outputs, they've all been our people, right? And our people still have a very important role to play here. However, what we want to try to do is try to democratize this, so we don't all have to be OCSMP level 4 in order to just be able to do basic engineering work. So in the past, whether it was drafting and authoring the model, whether it was interrogating the model, or doing traceability either across different tool types or to different activities in the lifecycle, what has generally happened is we've had teams of experts and maybe even junior resources going through and brute forcing it. And I'm not going to read every one of those 4 boxes there at the bottom, but what our hypothesis is in this future we'll be able to use agents that have been trained to be like, whether it's a safety expert, a zero trust architecture expert, or airworthiness, right? Those we can then spin up teams of those, point them at our models, and then ask them questions based off of a requirements change. So let's say we see our max altitude, we expect to see a 10% increase. I should be able then to go ask my agentic OS, look at my solution architecture, look at my system design, and generate for me a new functional architecture and highlight the impacts and the changes based off of that requirements change. AI goes and does its work. It generates an output. It generates a diff file, probably even provides me a couple insights. And then I sick my teams of engineers who I have been really teaching the systems engineering domain, not the modeling domain, to then go validate those things and then work with the agents to really get to some changes that are going to get us to the updated definition and system design faster. Once that's done, we commit it into the repository, and now it is usable and for all of our other teams, whether they're working in the model or they're working in CAD. And so that begins to activate a more agile approach, where if we're treating the model like source code, the pipeline can just write itself. So our view is that making any progress in this domain is going to add immediate value. So even if it's simply just to start working through Git repositories to do some of the model management and do the peer review of those without needing the customized MBSE tools that we've always used, that's going to get to an enhanced collaboration, which is going to improve the quality of our teams. And then once we start seeing that value, it's only going to become natural for us to move into the next phase, where we're starting to optimize a little bit more, putting into place just automated quality checks using those existing and growing repositories. From there, that turns into a much longer term vision where digital engineering is just self-optimizing, and where we have this entire that view of the integrated state that I mentioned before, and they're all working together in that hub and spoke model that we talked about to deploy, integrate, improve, optimize at a rapid scale in the type of sprint cycles that our software peers have all come to know and be famous for. So, in summary, the future of engineering is all of our engineering disciplines, not just the classical hardware, electrical, all of them working together by using artificial intelligence as a way to just have a natural language conversation with our most technical knowledge, and then managing the changes to that based off of the debate that we're going to have through CI/CD pipelines and DevSecOps to make one integrated digital thread. And that is how we're going to lead into this future where digital engineering is really expanding. Thank you very much. I welcome your questions.